Hello again and welcome to the second part of solving or finding the integrations using substitution method. So in here, let's start with the question 17. In here we have integration of 1 over square root of u multiplied by square root of u plus 1. Now the derivative of square root of u plus 1 is equal to 1 over 2 square root of u. We can find this part 1 over square root of u over here. So directly my assumption it will be u equal, or let's say we need another variable because in here we already have u, so I will say x. So x is equal to square root of u plus 1 dx equal to 1 over 2 square root of u du. Now we will solve for du, so this is equal to 2 square root of u dx equal to du. Now start with the substitution. 1 over square root of u multiplied by x dot, in here I will say 2 square root of u dx. Now square root of u is square root of u. The integration of 1 over x is ln x, and in here we have 2, so 2 ln x plus c. Now I'll put my assumption back again, so 2 ln square root of u plus 1 plus c. Now from the properties of the ln, we can put the 2 as a power over here. So be careful from that. If you would like to simplify it more and more. So in here, let's move to question 18. In here we have v, integration of v over v squared plus 4. Now let's think, before starting with the substitution, we can solve the question by substitution method, but in here, the derivative of the denominator, the denominator is equal to v squared plus 4. Now the derivative of the denominator is equal to 2v plus 0, okay, which is 2v. We can find of the part of that derivative in the numerator, which is v. So if we multiply by 2 and divide by 2, it's like we've done nothing. It's because in here 2 over 2 is equal to 1. So now the derivative of the denominator is equal to the numerator, which is the rule of the ln. So in here 1 over 2 multiplied by ln v square plus 4, then plus c. That's it. So without using the substitution method. If you would like to use the substitution method, you can substitute v squared plus 4 as u, then you can solve the question. But this is easier. Okay, so let's see this question. In here we have integration of 4 over x multiplied by ln x plus 1. Now the derivative of ln x plus 1 is 1 over x, which we can find it over here. We have x in the denominator. So my substitution, obviously, it will be ln x plus 1. Now du equal to 1 over x dx, then x du equal to dx. Start with the substitution. 4 over x multiplied by u square dot x du, x with x eliminated, then that will be integration of 4u to the power minus 2 du. Now I will add 1 and divide by, once you add 1, it will be minus 2 plus 1, which is equal to minus 1, so I'll divide by minus 1. So 4u to the power minus 1 divided by minus 1 plus c. Okay, in here I can write my assumption back again, which is 4. Instead of u to the power minus 1, this is minus 4. This is the minus. Okay, now I will write 1 over u. So 1 over u, then put the assumption back. So it will be 1 over ln x plus 1 Okay, then I will say plus c. That's it. This is the solution. Now the integration for question 20, we have a rule for finding the integration of tan 2x, but if, let's say, if you forget the rule. Okay, so how to solve this question? So this is the integration of tan 2x. Tan x is equal to sine x over cosine x. This is an identity. Okay, so tan 2x is equal to sine 2x divided by cosine 2x dx. Now let's see the denominator. The derivative of the denominator, cosine, the derivative of cosine 2x is equal to, so cosine 2x, the derivative for that is equal to minus sine 2x multiplied by the derivative of what inside, which is 2, using the chain rule. So this is minus 2 sine 2x. Now look at this. The derivative of cosine 2x is equal to minus 2 sine 2x. So part of the derivative, we can find it over here. So we can multiply by minus 2 and divide by minus 2. So 1 over minus 2, and here minus 2 multiplied by sine 2x over cosine 2x. It's like we've done nothing over here, because I've multiplied and I divide. So in here, 1 over minus 2, okay, ln cosine 2x plus c. Now if you would like to solve the question directly, we have the rule, which is integration of tan ax dx. This is equal to minus ln cosine ax, okay, divided by a plus c. This is the rule that we have learned before in the class, which is, you can find it in the PDF file that in our group. So that's it. So let's move directly to question 21. So in this question, we can say in here the integration of sine inverse x cubed, then divided by square root of 1 minus x squared. Now the derivative of sine inverse of x, sine inverse, sorry, this is inverse. Okay. So sine inverse of x, the derivative for that is 1 over square root of 1 minus x squared. We can find its derivative over here. So obviously the assumption it will be used equal to sine inverse of x. Okay, so now du equal to 1 over square root of 1 minus x squared dx. Now square root of 1 minus x squared du equal to dx, and I'll start the substitution. This is u cubed divided by, in here we have square root of 1 minus x squared multiplied by square root of 1 minus x squared du. Okay, so now this with this eliminated, the integration of u cubed is u to the power 4 over 4 plus c, which is sine inverse x to the power 4 over 4 plus c. Yes, that's it. This is my answer for question 21. Okay, what about question 22? So for question 22, we have x squared sine our secant x cubed square. okay, dx. Now obviously the derivative of x cubed is 3x squared, so that means in here, that means I have to substitute, or the assumption it will be u is equal to x squared cubed, sorry, because the derivative of x cubed does exist over here, which is x squared, 3x squared. So du equal to 3x squared dx. Now du over 3x squared is equal to dx. Directly I'll start with the substitution. X squared secant square u, then dot du over 3x squared. X squared with x squared eliminated. Okay, so I have the integration of secant square, so which is 1 over 3 tan u plus c. Now I'll put my assumption back. Tan x cubed to the plus c. That's it.